Hey guys, we are going to do some test prep and review today. We're going to have a test coming up in math later on this week, and it's going to be covering chapter 8, the concepts that relate to fractions. What is a fraction? What are the parts of a fraction, numerator, denominator? What are factors? What are multiples? How to find the greatest common factor, the least common multiple, how to divide a fraction and put it into a decimal, and those kinds of concepts, comparing fractions and so forth. So I just want to do a little bit of review with you. Again, after you watch this video, if you have any questions, please reach out to me. I'm happy to help you with it. You may want to go ahead and get your book, your math book, and I'm going to be using problems from pages 601, 602, 603. So what I would recommend you doing is I'm going to go over some of the problems. I don't know if we'll go over every single one of them, but I would recommend that you follow along with the video. And when I start to do a problem, pause the video, do the problem yourself, and then start the video again and see if you get the same answer, because I think that's going to be the easiest way to know whether you actually understand what you're doing. Okay, so on page 601, it's a vocabulary review, and we're just checking to make sure that we understand the terms. The first one says the blank is the least multiple other than 0 common to sets of multiples. What do you think that would be? Right, least common multiple. Number 2, fractions that name the same number, same amount in this hand as this hand, different fraction but same amount, would be equivalent fractions. Number 3, the top number of a fraction is called the, numerator. Number 4, when the numerator and the denominator have no common factor greater than 1, it means that we put it into what? It means that we put it into the simplest form. Number 5, the bottom number of a fraction is called the denominator. Number 6, a whole number that is a factor of 2 or more numbers is called a common factor. Number 7, the greatest of the common factors, kind of gives it away there, is the greatest common factor, or the GCF. And then number 8, the blank is the least common multiple of the denominators of the fractions. So least common multiple of fraction denominators could also be called least common denominator. So you can use the LCM as a common denominator. That's all that's telling you. All right, jumping over then to page 602, let's see if we can understand how to do some of these problems. It says, find the greatest common factor of each set of numbers. So the first set is 11 and 44. Again, I told you that you can use a couple of different styles. Use whatever works best for you. If you want to use factor trees, which I know a lot of you like to do that, we know that this one is already, 11 is already prime, so we don't need to do anything to that number, so it's already prime. And over here, 44 can be broken down into 4 and 11. 4 can be broken down again into 2 and 2, and there we have all of our prime factors. Then we go back to see which one is common. Well, 11 is the common one. So therefore, the greatest common factor would be 11. The greatest common factor of 11 and 44 is 11. If you would rather, you can write all of the factors of each number and then find the greatest one. That's fine too, if you'd rather do that. Let's just quickly review that method in case that's the way that you want to do it. The first factor set of 11, make sure that's still on the screen. The first factor set of 11 is 1 times 11. And then that's the only thing that can get you to 11. So therefore, that's a complete set right there. 2 doesn't work, 3, 4, 5. We keep going until we get to 11. And once we start repeating, we realize, okay, that we have a complete set. Over here with 44, we know that 1 and 44 works. Because 44 is even, we know that 2 will work. So 2 times 22 will work. Does 3 work? Well, let's go through our divisibility tests. 3 is a factor of a number if the number can be added up together and get something that 3 can divide into. So when I add 4 plus 4, I get 8. Does anything times 3 equal 8? No. So that means 3 is not going to work. My next option would be 4. I have 4 times 11. 5, okay, what's the divisibility test for 5? Well, the number has to end in a 0 in order for it to go in evenly, so 5 doesn't work. 6 will work only if 2 and 3 work. 2 works, but 3 isn't a factor. That means 6 isn't going to work. Nothing times 7 equals 44. So let's go on to 8. Anything times 8 equal 44? Nope. 9? 10? Nope. And then we are here, we are here at 11. Okay, so that means I have a complete set here and here. So now what I'm going to do is circle all of my factors that are common. I have 1 and I have 11. And the greatest common factor then between those sets would be 11. So that's another way for you to find the common factors. Just a quick review. Either way is fine with me, using factor trees or that method. It doesn't matter, whatever makes sense to you. Okay, let's move on now. The next one, number 10, says to find the greatest common factor of a set of 3 numbers. You can do the exact same thing. We've got 12, 21, and 30. So 12, 21, and 30. I'm writing kind of small, squishing them together so that it fits onto my screen here. I'm going to use factor trees. So 12, the factors there would be 3 and 4. Again, you can start with any factors here because eventually you'll get down to the same factor. So if you'd rather use 2 and 6, you can do that. You just don't ever want to use 1 times the number because you'll never get anywhere. So here we have 3 and 4. 3 is prime. 4 can be broken down into 2 times 2. Now we go to 21. What factor set equals 21? Right, 3 and 7, both are prime. And with 30, I'm going to use 5 and 6. 5 is prime. We can break 6 down into 2 and 3. So now I want to make sure I'm looking at each number set. What's common between all of them? The 3 is common. Is 2 common? Well, 2 is here and 2 is here, but it's not there, so I can't use it. 7, nope, nobody else has a 7. And 5, they don't all have a 5. So here, the greatest common factor is going to be 3. All right, so hopefully that makes sense to you. All right, moving on then. Let's go to the next one. Number 11, it says write each fraction in its simplest form. If the fraction is already in simplest form, just write the word simplified. So we have 3 36ths. And here's where you would use the greatest common factor. One example of how you would use it. We're trying to find a common factor of both 3 and 36. What can I divide both 3 and 36 by that would be the same? If you can't find a common factor, that means it's already in its most simple form. But here, can you think of something that I could divide both the 3 and the 36 by? Hopefully you're realizing that 3 would work. If you're not sure, that's when you can go back like we just did and go through and find a common factor. 3 divided by 3 is 1. 36 divided by 3 is 12. Therefore, and we'd say to ourselves then, okay, can I do this? The same thing here. Can I divide this down any further? Once you have 1 as your numerator, then you know that you're in its simplest form. But you're not always going to end up with 1 as your numerator. That's why you have to ask yourself that question. Can I divide this down even further? Can I simplify it even more? In this case, I can't, so the answer is 1/12. Number 12 says 25 30ths. 25 30ths. What can you divide 25 30ths by? That would be to have the same factor. What's a common factor there? Hopefully you're saying to yourself 5. 25 divided by 5 is 5. 30 divided by 5 is 6. Notice I'm putting an equal sign here because I'm showing that this amount is equal to this amount. They are equivalent. It's the same amount here as here. So my final answer, simplified, would be 5/6. Number 13 and 14, we're trying to find the least common multiple. And fortunately, we were able to be together for all of what we've done so far. Now we're moving into things where we had to do this apart. And so this is where it might get a little more tricky. Remember, a multiple is going to be the result of whatever number is used in the multiplication problem, whatever number we're trying to find. So in this case, we're looking for the least common multiple of 4 and 9. That means 4 is going to be used in the multiplication problem to get a multiple. And 9 is also going to be used in the multiplication problem to get the answer, to get a multiple. So we're looking for 4 and 9, the least common multiple of them. Okay, a lot of you like the popcorn method that I shared with you. You were telling me that. So let's do that. We're going to list multiples. Here, remember, we have to go back and forth, the popcorn method, back and forth. So the first one we're going to do is 1. We're using this as a factor in the problem. So 1 times 4 equals 4. 1 times 9 equals 9. Do I have a match? Nope. Now I'm going to go to my next choice, which is 2. We just go in order. 2 times 4 is 8. No matches. 2 times 9 is 18. Okay? No matches. Back over here to the 3. 3 times 4. Notice, remember, I'm using the 4 because that's the number we're looking for a multiple of as part of my multiplication problem. Over here, I'm using 9 as part of my multiplication problem. Why? Because I'm looking for a multiple of 9. So 3 times 4 equals 12. No matches yet. 3 times 9 equals 27. 4, that's my next choice, times the 4 that I'm trying to use is 16. My next choice over here is going to be 9. 4 times 9 is 36. And if I kept on doing this, and for the sake of time on my video recorder here, I don't want to keep going, but if I kept on going, I would eventually come up with 9 times 4 equals 36, which is my match. Sometimes when you're doing it on one side like this, you'll realize, oh, I can use that. So in this case, we can use 36 as our least common multiple. Okay, we're going to do the same thing for number 14, only you're trying to find it for 3 numbers, and eventually you would get to, go ahead and try that one on your own, and eventually you would get 70 as your answer. All right, let's go down to the next part where it says compare each pair of fractions. We're using greater than, less than, or equal to. So how do I compare fractions? Let's review that. We have 2/5 and 3/10. We're going to stack them. Anytime that you're dealing with 2 or more fractions, you're going to want to stack them so that you can make equivalent amounts, because right now we can't do anything with that. They're different. It's like apples and oranges. We want to turn them into something that they both are equivalent to, that have a common denominator. So what could we use here? You can use any common multiple of 5 and 10. You could use 500. You can use 100. You could use 20. You can use any multiple. Please understand that. A lot of people just look at the denominators and multiply them together. And you can do that, but you're just going to have to really work with bigger numbers when you do that. So some of you might look at that and say, I want to use 50. Okay, let's try it. Let's use 50. So we're going to turn both of these fractions into 50ths. How do I do that? Well, 5 goes into 50 how many times? In other words, what times 5 is going to get me 50? Whatever I do to the denominator, I'm going to do to the numerator. So 5 times 10 equals 50. Because I multiplied my denominator times 10, I want to multiply my numerator times 10. When I do that, I get 20. Down here, what am I doing to the 10 to get to 50? If I'm not sure, you just divide it. 50 divided by 10 equals 5. So that means I've multiplied my 10 times 5, because division and multiplication are inverse operations. They work together. Whatever I do here, I'm going to do up in my numerator. Okay, now I have the same thing. I have 50ths. That means I can work with it. 20 50ths is what than 15 50ths? Well, 20 50ths is greater than 15 50ths. So because 20 50ths represents 2/5 and 15 50ths represents 3/10, I can say that 2/5 is greater than 3/10. Okay, hopefully that makes sense. I want to show you that the same thing would be true if you used a different denominator. Some of you might say, well, why didn't you just use 10? And you can. You can just use 10. I like to do that when I see that the denominator that's already there will work. I like to just use what's already there. This fraction is going to stay the same because I'm using the same denominator. So that would be the same thing as 10 times 1 and 3 times 1. Okay, so that fraction stays the same. But how can I turn fifths into tenths? Well, I'm going to multiply. Remember, you're multiplying by one whole. It just looks different depending on what number you're using. In this case, we're using 2 halves as our whole. 5 times 2 is 10. 2 times 2 is 4. Okay, well, is 4/10 greater than, equal to, or less than 3/10? Sure, it's greater than. So you get the same answer either way. You would find out that that fraction, 2/5, is greater than 3/10. Okay, let's go through the next one. Number 16, we're dealing with 1/5 and 1/4. Go ahead and do that and see what you get. You can pause the video and I'll let you know what the answer is. The answer is less than. Good. 1/5 is less than 1/4. And then number 17, we have 3/4 and 18/24. You're going to need to do the same thing there. And when you do the same thing, find equivalent fractions with the same denominator. You would find out that 3/4 is equal to 18/24. All right, let's go to the last section then on page 602, where it says write each fraction as a decimal. You will see here the first one, number 18, it says 3/10. Sometimes you can actually hear the place value. In this case, tenths, you know that is a place value. Well, how would you write 3/10? You would write it like this. Before we started this whole decimals and fractions business, when I said to you, if I would have said to you at the beginning of the year, write 3/10, some of you would have just written it like that because you were familiar that 3/10 as a fraction looks like this. But we also learned this year that 3/10 just means you put the 3 into the tenths place. So they're the same. So that's how you would write it. So when you see a fraction like this, hopefully you can see right away that the decimal equivalency would be this amount. But sometimes we can't see it. Sometimes we can't hear it. So in number 19, it says 19/50ths. Okay, how would you do that? Well, you would this is the same thing as saying 19 divided by 50. 19 divided by 50. How do we do that? Well, we can't take 50 and put it into 19. But we learned how to do that. You put your decimal point here, put it straight up into your answer, add your zeros because you haven't changed your amount at all, and then you would divide. How many times does 50 go into 190? Goes in 3 times. 3 times 50 is 150. When I subtract, I get 40. I check it, and it works out. I keep going, bring down my 0. How many times does 50 go into 400? Well, it goes in 8 times. 8 times 50 is 400. That comes out evenly. I compare and I'm good. Nothing more to bring down. So my answer is 38/100ths. And you're going to keep doing that process for the next 4 problems. So go ahead and do that. Pause the video and then I'll let you know what the answers are. All right, the answer for number 20 is 0.5 or 5/10. The answer for number 21 is 2/10, 0.2. The answer for number 22 is 0.56 or 56/100ths. And then number 25 is 0.12, 12/100ths. Okay, so hopefully that review helps you and hopefully it makes sense. All right, see ya.